Welcome back to Goliath. Today we're going to be going over the NXP Freedom MCXW71, which is another board we're enabling on Bluetooth Cloud. I'm here with my buddy Mike. How you doing, Mike?
I'm doing pretty good. I'm excited to see yet another piece of hardware become a leaf node on our system.
Yeah, exactly. So we're enabling lots and lots of different vendors and different types of hardware, all Bluetooth based onto Goliath Bluetooth Cloud. I think the big difference, if you'll agree with me, is the fact that I'm going to be doing it today instead of you. So who knows where this will go?
I'm gonna enjoy just sitting here and doing nothing. I'm just kidding.
It's coaching. It's coaching.
Yeah, but I will say, whether you're the one doing the coding or not, it's exciting to see Bluetooth devices that don't have a network connection be able to send their data up to the cloud pretty easily. And so, yeah, I'm liking this series.
And without having to build a bespoke gateway as well, right? I think one thing we should call out is that Bluetooth stuff can connect to the cloud if you build kind of the full end-to-end. Even on Goliath, we've seen people building gateways that are completely custom, and they have maybe listening to nodes out in the world, but it's really the gateway is running Goliath code. It's listening to these devices, it's collating it, it's sending it back up to the cloud. The big difference now is that each of those individual leaf nodes, like Mike mentioned, out in the world, it has its own device record, and that's what we're going to be enabling here on this NXP one. Should also mention NXP. Mike already enabled this on the RW612, which is another NXP one. These two products are meant, oh, there it is, yes. These two products are really meant for thread first, right? So they have 802.15.4 on them. The RW612 also has Ethernet, also has Wi-Fi.
Yeah, I like that.
They all have Bluetooth. Yeah, exactly. It's super fast, super powerful. This one's kind of the baby brother. That's what we're going to enable here today. So this one truly is a leaf, both in a thread context and in a Bluetooth context. They all need Bluetooth for provisioning in thread networks. So
yeah,
and
now
that
that
one
you
was,
say that, we should do a stream at some point where we make this a gateway. I think that would be a lot of fun.
That's great. Yeah, that's a really good idea. And it was not too bad on the RW612 as well to get it, because it was in, all of these are in tree, right? That's kind of the key thing here for Zephyr based devices.
Yeah, and NXP seems to have pretty good support for both of these boards. Well, for the board I did anyway. I haven't tried the board that you're using, but the tools work for it, and I was up and running with that in a few minutes.
Yeah, great. Well, let's take a quick look at what this board looks like up close. I can both show here on my bench, and so this is the MCXW71. That's here. I believe there's a 72 as well. So this is the actual chipset. All this is the driver stuff over here. And there we go. This is the debugger on the back here. And then we do have a board plugged in, ready to hopefully talk to the cloud through that. And then over here, this is my gateway. This is my desktop gateway, as I call it. It's just a NRF 9160DK with a with a NRF 52840 acting as the Bluetooth HCI. And that's something that we've done in the past year. And let's take a quick look at just kind of what this looks like up close. So just to see, do I know how to zoom in my, yes. So that's what it looks like there, kind of without the headers, without all this stuff there. And it does have, as Mike and I talked about, pretty much the brightest LED I've ever seen in my life. This little guy will blind you, whatever it is, the RGB D13. Keep an eye out for that one. Watch your retinas.
Yeah, same on the RW612. I don't know. The NXP engineer is like, I want more power.
More power.
More lumens.
Yeah, right. So like we've been doing here, we've been starting from the Zephyr page. This one is supported in Zephyr, so that really gets us kind of moving forward in the right direction. And so we're able to kind of do all this stuff here. I would say a couple of call outs in terms of the things that are going to trip us up, trip other people up when they're doing Bluetooth on this board generally. You do need to install the blobs here, which are binaries coming from not just NXP, but in this case NXP. But basically these are binaries that go into some part of the chip you don't have source code access for, then you have to program it in. And then in our case,
kudos to whomever put this in on the Zephyr tree. But if you try to build without those blobs, it will tell you the command you need to fetch the blobs. And I'm very thankful for that.
Oh, really?
It'll print it right in the error message. It'll be like, run this command to fetch the blobs that you're looking for.
Well, actually, the other thing I was going to call out is this is not as integrated, at least for this one, was not as integrated. So you see a little further down the page here, NBU flashing. So basically, we are putting an HCI style thing on the some portion of the chip. That's where the blob is going. This actually requires a standalone BL host. So I don't know if that was the same on the RW612.
No, that's different. Yeah.
Okay. Yeah. So that was a little bit different. There are directions here. It was relatively straightforward. I'm on a Mac right now. I had to just kind of download a binary, tell my Mac that everything was going to be fine, that it's safe, and don't worry, just run this binary from the internet. But once I did that, it did work. There are some directions elsewhere online. Much like any other thing, boot here. If you don't have it, if like we've seen a couple of times when the HE is not there, it's likely to seg fault. So if you see the screen of red, that might be what you should be looking for on your own designs. So.
Yeah, I suppose when it's calling those blobs, it just calls an address, and if the right code isn't there, then nothing happens.
That's right. Yeah, I think, yeah, exactly. It's just an empty space or garbage file. Who knows? So, yeah, and it is this weird SB3 as well. So I downloaded it, bootloaded it in there, and then once that is up and going. All right. So first things first, we should probably go into some Zephyr files and maybe just see if we can get this thing to build. Like I said, I've already gotten the programmer to work. One other thing that was a tricky thing here. Mike did some sleuthing. They put in, what's it called? Sorry, I keep forgetting the name of it. Link server support, which is their onboard programmer. That went in December of 2024. Our current Bluetooth build, like you'll see here in a second, is tied to a Zephyr build from November. So we just didn't have access to it. So 4.0 did not have access to it. 4.1 does. So if you're running something, if you're trying to run Zephyr before 4.1, that will not work as far as I can tell. So you'll see how we specifically call it out here in the build. All right. I think that's good. Is that enough?
Yeah. Was there anything you had to do after uploading to 4.1, or did WestFlash just work then?
WestFlash has worked then, yeah. So it has its own runner.
Yeah.
Because I had put in as part of those directions, like that BL host. Sorry, I'm confusing the two now. Where was it? Sorry, there is. I think I might have had to add that to the path. I might be confused on which one's which now. Path. No, I'm sorry. I think it did just work. I'm sorry about that. Yeah. Okay. So I think that did just work. Once the debugger is up and working. So this is the file we're going to work here. This is from the pouch. But before we do that, let's just go and build hello. So let's actually do that down here. So let's go into CD deps, Zephyr, samples, basic, Blinky. Okay. And then let's do, let's get cheeky and see if I can do a West build here. There we go. So West build, and then we're going to do a pristine build. This is going to be in this folder, so in the Blinky folder in the samples. So we are changing the dependency, but we won't commit any of those changes. And then the board we're building for is this Freedom MCXW71. All right, and then that's going to be a dot. Oops.
Yeah, and I really like running these basic samples. So basic Blinky, and then hello world on any board that I'm going to run. And even when I do custom board definitions, I always try to make sure those board definitions will run on those, because it's just like a source of truth. Like, it's in the tree. Can you just type this command to get your board? You know that, one, you can talk to it. You can get UART with the hello, or you know the clock is running correctly with the Blinky.
Yep, exactly. All right, so we're going to build this in this folder. Hopefully it all builds. Like Mike always talks about, make sure you're looking at the output to see if there's any build errors. I think I'll see, yeah, so Zephyr version 4.1.0, we should see that here. And that ultimately, we'll show that in the next section on how we actually set that in our manifests. And then let's try a West Flash. Flash it. There we go. And let me pull this on screen so we have. I actually sent this to Mike on Friday. I see it. When I was showing Mike, I was like, "This is the most anticlimactic thing ever." It's a blinking LED. This is the output of my week. So we're up. We're blinking. We're good, right? Okay. And so now let's talk a little bit about the actual build. What we're going to build other than Blinky, right? So now I've got Blinky loaded on there. I actually still have. I already do have on this chip. I do have the Bluetooth HCI on there. And now it's going to be
And that's
about
just the binary blobs that you downloaded, right? You don't have to do anything like compile that. You just had to download it.
Yeah, that's right. Yeah. So if we go back to the folder here, or sorry, the document here, the Zephyr thing. So this West blobs fetch, this ultimately it was going out and it was grabbing an MCXW71 binary. And then the binary operation that's down here, it looked like this. I basically ran this script BL host, which I'm not sure is mapped any longer. BL host. BL host is still mapped in my path. Basically, I ran BL host and then I pointed at the right serial terminal, and then I gave it the file location. I think what actually happened is I must have loaded that programmer somewhere in like a different terminal, not in the in the terminal of VS Code. I think that's actually what happened there. So I don't think I've restarted the computer since then. So that's why it wasn't there. Anyways, so what am I doing now? I am going to build. Let's go through this actual build, what this looks like. So before we look at the boards thing, so this is actually based on what I built a standalone node repository based on Pouch. So Golioth's Pouch is the capability that we have to wrap up non-IP data and then send it through a transport. In this case, it's going to be Bluetooth. And then it can talk through a gateway running that same transport. So that's actually this gateway here is running the GAT transport, BLE GAT transport. I know there's so many acronyms.
Yeah.
And this is our standard Bluetooth design. I didn't have to do anything there, our Bluetooth gateway design. So now this is going to be building a Pouch example, but I'm going to, instead of building it in the examples folder like Mike showed, the way I like to do this is closer to like our reference designs where we call Pouch as a dependency. Now that had caused some issues based on this Zephyr 4.0 versus 4.1. Basically, once Pouch is pulled up to a newer version, it won't be a problem. But in this case, what we had to do is we had to call out 4.1.0 in order to get that link server support. And then probably the more important thing is that we had to call out HAL NXP because, and this is what Mike showed in the ST Micro, the STM32 stream, where we need to have the hardware specific hardware abstraction layer programmed into the repository we're building with.
And if you don't want to figure this stuff out, you can just remove the name allow list and it'll pull in the entire, everything that Zephyr knows about as being a repository, it'll pull in. But if you don't have these HALs, you get like a series of very confusing errors, like build errors, and you won't be able to figure out like what's going on. You just have to kind of intuit like, oh yeah, I probably don't have the board file for this vendor.
Yep. Yeah, they were weird. It was like there's kconfig and there was, I think, device tree thing. So yep, that is probably a good first troubleshooting step is to just rip this out. Okay, so called out 4.1.0, called out HAL NXP, and then ultimately then we needed to call out Pouch as well, because Pouch is the thing that enables wrapping up data. In terms of the demo, it actually doesn't look that different normally. I'm going to show it is a little bit different here. This is closer to the weather sample app that I showed on the sneak peek behind the Bluetooth to cloud settings. So there's another video that we can go link in below as well. But normally what we do is this kind of block right here. We just send a fixed amount. This is what Mike usually shows first. We just say, hey, the temperature is 33. We stream that up. Other things that are important here, we need to pull in the specific device ID that we've created on the console. So I've already done that for this board, and that's that device ID. And I renamed the device name as well. All right, so now I think we should be able to build this. I guess I could switch it over to this boring one first if we wanted. I can just do that. And we'll do that. And hit save. Oh, I need to do one other thing. Turn off the sensors in it. And let's build it. Oh, I need to go to the right directory. Okay, it's a little bigger. Let's build. Oh, and that's the wrong folder. And now we're going to build in the app folder because we're in this top level here. We need to call out the app folder as a thing there. I don't know what that was. What did I just do?
Looks like a diff.
Oh,
you probably just close that tab.
Yeah. Yeah, that was a diff. You're right. Okay, let's try that out. Okay, so again, we're building for 4.1.0. We're calling out that stuff there. And now this is a larger build because this does have pouch and has Bluetooth stuff in there as well. While that's happening, I'm going to also turn on my gateway because this thing needs to boot up and connect over cellular. In fact, let's see if this works this far away from the window. Sometimes I give it an extra antenna boost. So let me do that.
Do you have an external antenna for your DK?
Yep.
That's cool.
I'll mess around, Mike. I got places to be, you know. All right, so let's go look at the output logging for here. Oh, that's the problem. Okay. All right, so this is the gateway. I don't know what this is on the right here.
On the left, you mean? I didn't realize that Blinky outputs to UART, but I guess it does.
That is the old one. Oh, I didn't flash it yet.
Yeah.
Yeah, we actually, I think we might have modified that at one point during testing.
Okay.
I was wondering, I was like, I could have swore we made this a Bluetooth device. Okay, so on the right side is the gateway. The gateway is up and scanning. So once this programs.
Did you actually change anything? It just didn't work the first time.
Okay, so now on the left side is the, that's this device here. So that's the left pane, and this is the right pane. And what I expect to see is it will start, now that this is scanning for Bluetooth stuff, this is advertising. They should talk to each other, and much like we've shown in other videos, there we go. Look at that. We've gotten our first packet going through here. So there we go.
And
there
it's
is
33 degrees C in your house. Crazy.
And yeah. Let's go and look at that on the console real quick. So if we look at the devices, we should see that it's connected to the network here. So this is our latest device. It's got that nice visualization of high volume red laser beams, I think. And then if we click in devices here, we should see this one just connected a few seconds ago. And yes, it is streaming here. Go to LateTV stream. We see the temperature is 33. Anyways, so now what we're showing is that we're going to show. So this was just this device. So the Bluetooth device was just streaming fake data up now. So now we're going to pull in this BME 280, which is this chip here. There is actually an accelerometer on board as well. Usually you can see that on the Zephyr page. So there was an accelerometer here somewhere.
Under sensors, I think, down at the bottom line.
Oh yeah, sensors. Yep, there you go. I'm actually, it's interesting there's an MMU on here. I didn't realize that. Neither here nor there. So let's go look at what that looks like in terms of enabling that. So the way I've done it in the past is I basically just ripped out Mike's code from the cold chain asset monitor, one of our reference designs. And so that's just this code here. Basically, it's just got a thread that's going out, reading the I2C device, pulling it in, and then the data is available. So that does it every second. And then every 20 seconds, which is how often I believe we're advertising here. The sync period is 20 seconds. So every 20 seconds, we just grab the latest temperature and send that up to the cloud. So to enable this, let's go to main.c. I'll just swap around the commented code. Comment this out.
Can we take a look at that block that you just uncommented?
Sure. Yes.
Okay, I see.
Yeah. And so this is basically, there is a single call from the main function over to the app weather.h. There's a public function there, not public, but there's a function that's available there in the header, and that's get latest weather. So we just call that, and when it's available, then we upload that. Let's see. So I think that's all it takes. Let's try rebuilding here. I'm going to do.
Do you want to look at the device tree stuff that you added?
Thank
to
you.
make that node work.
Yes. That is here. So I made a board overlay rather. And then, so you might be wondering, how did I figure out this LP ICE2C1? Because I definitely got that wrong the first time. And the way that I did that is because this board is in tree, I can go into our depths folder, go into Zephyr, go into boards, go into NXP. Just for the record, I did this without Mike's help this time. This one time I did this part without Mike's help. And then go to MCXW71, and then look at what they have on the DTS here. So this is basically showing what hardware is available in the device tree for this board. So we can see the board here, the various aliases, the Zephyr memory things, user LEDs, PWM LEDs, obviously on 100 because it wants to burn my retinas out. And so what I look for was just I2C, just search for I2C. And then that's how I knew that it was called LP I2C1. Interestingly, there's only one I2C bus on this chipset.
Oh, interesting. Okay.
Yeah, I was surprised by that. Usually there's a couple, and it's pretty simple. And then there's pin control rather available, and yeah. So that's how I pulled that.
So they just have that mapped to the click header already, which is pretty convenient.
That's right. I think it actually must be mapped to both because there's only one. It must be mapped to the click header and the Uno header, right? Because the Uno's headers also have I2C on them, so it must be going to both. Yeah. But because they're running into each other, you wouldn't be able to use both anyways, which is not a big deal. All right, so then in the overlay file, I call it the node name, call it the device we're going to be using at the address we're looking for, call it compatible, which is something we've shown a lot before, and presto changeo, it just kind of compiles. So let's build this different version here.
We found a lot that if you get stuck on the compiling, just deleting your build folder and trying again can be a good remedy.
Yeah, we're trying to program it a second time apparently.
Yeah, that was weird.
Weird.
Timing, I guess, timing issue.
Could be, yeah. All right, so now we're seeing it boot up with the new Zephyr build. And now this is it reading it every 1 second. As Mike and I were talking about right before recording, probably would have made sense to put some actual readings in here.
And those are not those are local reads. So that's when it's updating its local stored value. And then on the right, we see it connect and read.
Yeah. Oh, then it does. Oh, it does it here. See.
Right.
Yeah. And then then we can kind of see with okay.
That's just the UART can't display things fast enough, right?
Oh yeah. Okay. Yeah. That has not crashed, which is great.
Yeah.
Okay. And then so we see temperature, we see pressure, we see humidity. H is up here, HUM. And yeah, so now we're sending that to the cloud. We should start seeing this data. So now we see this for this device.
All right.
And it's actually 28 degrees in here, Mike.
That's a lot more comfortable.
Yeah, better than 33. Yeah.
Better than 33.
Yeah. All right, so on this board here, so now the MCXW71 is enabled on Golioth's Bluetooth to Cloud, which is super exciting. I mean, each new one we add here, in this case, we're able now to plug into the various headers. We can use the click header. We can use the other stuff that's on board. And, kind of the general promise of Zephyr as well is that you have more choice as a designer. You can go and choose different chipsets. You can choose, better, as you look through the specs, the firmware dependent nature kind of drops a little bit each time. As Zephyr continues to get better, which is very, very exciting for us.
Yeah, and I think, looking at having a fleet of Bluetooth devices and actually collecting the data for them has traditionally been very difficult. And this kind of abstracts all of that away. So you just have the pouch protocol, which is like loading up your data into a certain package that gets sent through GATT, and the gateway takes care of the rest of it. And of course, the Golioth Cloud, it allows you to visualize it or pipe it to an external service or manipulate it and do something with it.
Exactly. If you are a Bluetooth and or other type of IoT developer, we would love to talk to you. We are still in private access for this device, or sorry, for this program, but we will very soon be in public beta and then full general availability. If you want to get an early access kind of look here, this actually is a live repository public on the internet, but you won't actually be able to use it until you're enabled on the Golioth cloud, and that's where you got to give us a shout. There's a link here as well, and we'll have that, of course, down below in the YouTube links and also on our blog post associated with this. So if you're interested in getting your NXP, well, I guess what do we have now? So now you have NXP, Nordic, ST, and more on the way. All right, Mike, thanks for sticking with me, and we'll see you in the next one.
Great job, Chris. Bye.